If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in machine series. So in this lecture again we will be solving 5 questions starting from question number 101 to question number 105. Okay, then let's try to solve these questions. Okay, in question number 101, in a transformer, 0 voltage regulation at full load is, whether it is possible or not possible or not. So you know the voltage regulation formula, it was Ia into Ra cos phi plus x sin phi, that divided by this one. So the numerator is this one, so this should be equal to 0 for voltage regulation. This one should be equal to 0, this because this was the variation. Okay, so this is plus for lagging, this is plus for lagging, and this is minus for leading. So if I take lagging, if this is given, because my regulation has to be 0, so for lagging it is plus, so I get cancelled. So your sin phi by tan phi, that is your power factor, sin phi by cos phi, that should be equal to minus Ra by x. That means your tan phi should be negative, which is not possible. We know power factor angle is not that tan phi will be negative, because power is angle between 0 to 90 it becomes. Okay, so this is not possible. Okay, so if you take the leading one now, so it will be Ra cos phi minus x sin phi equal to 0, which will give you tan phi equal to Ra by x. So this is feasible. You can have a phi between 0 to 90. So you can say this power is power factor angle. The angle phi is the angle between V and I. So that angle should be 0 to 90 to your intention, because if your angle goes beyond 90, then reverse power flows. So your angle should be 0 to 19, and it is okay. That means tan should be positive. So it is possible if it is a leading power factor load. Then only you can find phi, which power factor angle which satisfies this relation Ra by x also. That is Ra and x is transformer internal resistance and leakage reactance. So that is possible to find some load where both is equal. But it is not possible because your phi should lie between 90, so it cannot be negative. So it is possible at leading power factor load, that is option C. Now if you come to 102, a single phase 50 kVA 250 by these two winding transformer has an efficiency 95% at full load, unity power factor. If it is reconfigured as 507 by 750 auto transformer, its efficiency in the new rated load at unity power factor. So what is new rated load? Let me see that one. So if it is a 500 by this one, so obviously this winding is 500 and this is 250, so total winding you are getting 750. So what it is rating? 750 multiplies by the current that it can allow this winding. So this winding is coming from this transformer. So what is the maximum current they have set for this winding? So that much current only you can take out from it. So it will be 50 into 10 to the power 3 divided by 250. Because it is single phase, no root 3 is coming. Okay, so if you do this one, it is 150 kVA. It is 3, so it is 150 kVA. So this is the maximum power rating. Now see this transformer. This transformer is already given 95% efficiency. That means from here you can calculate the loss. So your output was 50 into unity power factor, that is 1. So 50 kilowatt divided by 50 kilowatt plus some loss. I don't know whatever loss it is. So that total loss is given as 90.95. So from here you can calculate your loss. The loss of the transformer is 2.63. Now you are taking same rated current with here, because you are taking the maximum current that is allowing from these windings. So you are taking that maximum. So maximum same loss will occur. Same copper loss and coal loss will occur. Coal loss will be always same because it is the magnetization plus portion, and copper loss is the rated current when you flow through this winding. So these windings rated current is flowing. So your total loss will remain same. Core plus copper loss, okay. Magnetization part and then copper loss, so it will remain same. So now your output is 150 into unity means 1, so 150 into 1 plus this loss, so output by output plus loss, so into 100, that will give you 98.276%. so that is your option C. So in question number 103, three single phase transformers are connected in the form of transformer bank as shown in the figure. The transformers are connected in the following. The transformer connections will be represented. So there are different methods. It is start to delta. You have seen start delta never becomes 0, never becomes 6. Either it is plus 30 or minus 30. Okay, it can be done in this way. Suppose if I take this winding, suppose this is winding 1, winding 2 and then winding 3. So name this winding. This is your primary A2, A1. So AT is your output terminal, A1 is this one. Similarly ABC, we always follow this convention, ABC, C2, C1. Now you can see this winding, A2, A1 winding, you cannot change this orientation. This A2 winding, A2, A1, You have to maintain this orientation. You have taken it vertical, so this same winding you take, you cannot change this one if you are doing winding diagram. So it is A2 A1. You have to make delta using this. So you can this, and you have to see from where you are taking your output. You can draw it this also. You can put B1 B2 here and C1 C2. You can, there are two ways you can do. One is this way also, and one is this way. Two delta can be formed either this way or this way. That you have to be see. A2 is connected with 1. So A1, which one is connected with A1? A1 is connected with B2. So if you take this winding, if you place here, then it is connected with, see, B2 is connected with A1. You can see B2 is connected with A1. These are small A1s, you can, otherwise you will get confused. The same replica of this one. So it is obviously B1. So obviously this one left is C1. So according to connection, this delta will be this side or that side. So that you have to think. Accordingly, it will be actually YD1 or YD11. So you can see this is B1 is connected with C2. So this terminal is C2, this is C1. So you can see these windings, this orientation should remain same. Now it was star, originally it was star. So you try to make a star from here. So this star is here. So this angle actually 30-degree angle because it is face to line, this angle. So you can see this was your original star. Now it is going in this direction. So this star was at, if you take it is 12. Now this star, equivalent star, resultant star is coming at 1. So you have to compare the original, whatever it was there, it is star. So next you have to come to star. If it is delta, originally it was delta, you have to make a delta in the secondary. Here it is star, so I am making star here. So you compare this star and this star, see the angle difference. It is at 12, it is at 1. So it will be YD1. Similarly, if your delta could have been this side, then you can obviously feel your star will now be in this direction, 11. In that case, it would have been 11. So this is the way to write it in case of if you are taking wind. So in question number 104, it is desired to measure a parameter of 230 by 115 2 kVA single phase transformer. The following wattmeters are available: wattmeter 1, 2, 3, 4. The wattmeters used in open circuit test and short circuit test. So you have seen in open circuit test only magnetization current will there. So there will be much more in reactance. So that power factor will be very, very low. So you will be using low power factor, and magnetization current is very less because it is 2 kVA. So you can see what current it will take. So 2 kVA divided by 230, it will be hardly 10 ampere, less than 10 ampere is the rated current, and magnetization current will be very, very low. So you can easily use 5 ampere. So you will use the low rating wattmeters. This is the best suited. Low power factor and current is not required 10 ampere, 5 ampere is sufficient. So you will be using W2 for OCC. And your short circuit test, because the entire winding is short circuit, then winding resistance will come, so power factor gets high, so it will be high power factor, and current is also very high, so you will be using high current wattmeter, that is W3 for short circuit. So it is W2 and W3, that is your option D. So in 105, the core of a two winding transformer is subjected to a magnetic flux variation as indicated in the figure. The induced EMF in the secondary winding will be a function of. So secondary EMF, induced EMF, if it is a phi, the core flux is this one, then it is always d phi by dt. So if there is a change, then there will be the EMF induced. If there is a positive change, then positive EMF induced. If there is a negative change, so negative induced EMF. So the answer will be this one, you can say. So this E is equal to actually minus and d phi by dt. So we can think of that it is coming negative, but see this, it is minus and d phi by dt. Now you can see your d phi by dt is positive here, so your induced EMF will be negative. But you see this, how this induced EMF will be there. If you see your phi, your current is flowing in this direction, that's why phi is in this direction. That is okay using right hand rule. But for phi, if you want to find that EMF, next you will be using left hand rule, because generation is always right hand and this is something of motoring action, so this is your left hand use. So if this is your phi, so your current is in this direction, so current is coming out of this now, so this direction current, so this becomes positive actually, but they have given reverse of this one. So what they have given, VRS is the minus of what you will get. You will be getting in this way, this is plus, this is minus, so that is actually negative getting, because ERS is minus d and d phi by dt, and they have given just reverse of this one. So minus of what you are getting current in these directions, that means current is flowing out, so it is out, so it was plus minus as per load convention. So this would have been proper way of getting what is we are getting from this one, but they have given just reverse of this one. So ultimately you will get, if it is a positive, so it is increasing, and if it is a flat, then it is d phi by dt is 0, so middle portion it is 0, it is decreasing, negative slope, so it will be negative. So that is your option A. No need to calculate with the others is not, you no need to calculate 24. You can also calculate it because n is 200. N is 200 and d5 by dt. What is the change in 5.12? What is the change in this one? That is 1. So you can say it is 24 volt. And here this change is in the second slope it is 0.2, but this is 0.5. That's why it is doubled, minus 48. So it is d5 by dt. Only the directions that you have to see. If the directions had been plus minus, here plus, here minus, then it would have been this one. Otherwise they have given this one. It is minus and d5 by dt, okay, but you see the directions where it is minus and d5 by dt and then reverse it. If you like the video, then press the like button and please give your valuable comments in the comment section.